Welcome all for the video tutorial on machine learning, and today we are going to see about fourth module, which is about Bayesian learning. The content of the fourth module are as follows. First session will be about the introduction to the Bayes theorem, followed by Bayes theorem and concept learning, and we have maximum likelihood and least square error hypothesis, followed by maximum likelihood for predicting probabilities. Then we have MDL principle, followed by naive Bayes classifier, and we have Bayesian belief network. Finally, we have EM algorithm in the fourth module. We'll start with the introduction to the Bayes theorem. How does the machine learns? Okay, we give an input. Okay, first we train the data in the machine, followed by either it is going to predict your data or it is going to classify the data. Okay, you're going to create a model which is going to carry out any of the application. Okay, and we give an input. That input will be processed. For this processing, we use mathematical concepts. Okay, and the most widely used concept is the probability concept, and this is the foundation of our machine learning algorithm. We make a machine to learn, and that learning will be executed through the algorithms, and this probability concept is used in the widely used machine learning algorithm. We make a probability prediction between 0 and 1, which is going to indicate the whether it is true or false. Example for probability, application of probability is when we toss a coin. Okay, what is the probability of getting a head or tail? It is 0.5. Okay, same, this is simple concept of probability. Even we apply the same thing for the prediction in the machine learning. For either prediction or classification, we will be using the concept of probability, and under probability we will be using the Bayesian theorem. Okay, Bayesian theorem is the most basic probability concept used in the many of the machine learning algorithms. Generally, what is probability? Probability we define as the occurrence of an event. What is the chances of occurrence of an event? We specify that as a probability. Okay, we'll see what is conditional probability. The conditional probability is nothing but a condition will be given, and the execution will be happening after an execution of one other process. Okay, you have an event. Okay, if you have two events, one event will be occurring, and outcome of that event, your other event will be taking place. That is the conditional probability. Okay, you give a condition over there, and in that condition it will be stating whether the event has occurred or what, and what is the event which has been occurred and which event has followed by that. Okay, you give a specific condition over there, and we apply a probability. We find a probability of occurrence, and we are supposed to know two types of probability, conditional probability we have. One is independent event, the other one is dependent event. We'll see what is independent event. The independent event is nothing but it doesn't have any relationship between the other event that is occurring. Okay, it is going to, that particular event is going to occur independently, or the outcome of that event will not affect the other event. This is what we say it as independent event. This event will not affect the probability of the other event. Okay, for example, tossing a coin is a very good example for independent event. So when I toss a coin, okay, when I am tossing a coin for 5 times, when I toss a coin at first time, I may get either a head or tail. Okay, that result output is not going to reflect when I toss the same coin the second time. Okay, all the time when I am tossing, it is independent. All the events what is occurring is independent of the other event. So these type of event we say it as independent event. The occurrence of one event will not affect the other event. We'll see what is the probability of an independent event. The probability of event happening is specified as number of ways it can happen divided by the total number of outcomes. Okay, and the formula what we use is the probability of A and B will be probability of A multiplied with probability of B. For example, what is the probability of getting a head when we toss a coin. Okay, so what are all the ways it can happen? So what are the number of ways it can happen? We need head as the outcome. Okay, what are the actual total number of outcome we have? We have either head or tail. So what is the formula we are using here? Number of ways it can happen and the total number of outcomes. So what is our expectation here? We are supposed to get a head. So what is that? Among two instance, we need one instance, that is 1 by 2. So the probability will be 1 by 2, which is 0.5. And the next type of conditional probability is your dependent event. Here, the occurrence of one event will affect the other event. So outcome of one event will be carried out and it will be affecting the probability of the other event. Okay, the example, very good example, we'll see that if I have 5 balls, okay, among that 3 are red balls and 2 are blue balls. So what is the probability of choosing a red ball? Okay, so at the first time, what happens when I pick a ball? What is the probability here? I have 3 by, or how many balls you have? 3 balls out of 5. Okay, so it is 3 by 5. Okay, and the next time when I pick up a ball, what is the probability of getting the red ball again? Already one ball I have taken. So what is the remaining? So now it is 2 balls left out and the probability is based on that. Okay, then next time when I need to pick up the red ball, what is the probability? Okay, I have already taken 2 balls, so it will be 1 in 4. Okay, this is how what happens here. One event, outcome of one event is affecting the outcome of the other event. This types of events we say that as an dependent event in a conditional probability. We'll see the probability of dependent event. Okay, the probability of A and B will be, P of A and B is equal to P of A multiplied with probability of B given A. Okay, generally if it is independent event, we will be having probability of A multiplied with the probability of B. Here, since the occurrence of one event is affecting the other event, here we give the formula as the probability of A and B will be probability of A multiplied with the probability of B given the A. A has occurred before the B. It means what is B given A here? A has occurred before the event B. These are all the basic concepts we have under the probability, and we use this concept in the Bayes theorem. Normally, what happens in machine learning? How does the classification of problem occurs here? We have a training data. Okay, we have a training data and we represent that in H of D. Okay, that H of D is D is the training data and H of D will be your hypothesis of that particular data. Okay, and we give an input there and you have already trained a machine, okay, with certain sort of data sets. Okay, that is what supervised learning. Now when you give an input, it is going to detect that input, okay, whether that given input is already there in your data set. If you have the same data in the data set, it is going to predict and it is going to give the output. If not, it is going to give you are going to calculate the error. What is the formula we use to calculate the error? Error is given by target output minus actual output. We have already seen this in back propagation. When we don't get the expected output, it means that there is an error in your system. So what we do, we back propagate there and we find out the error. How do we find the error? We try the weights with different possibilities. Okay, when you try with a certain input, when you multiply that with a weight, but the final output what you obtain is not your expected output, then we back propagate and we try with the other possibilities of weights. So now we'll see how Bayesian framework is used here. Okay, here this Bayesian framework will allow us to predict a knowledge by using the observed data and the prior knowledge. What is this prior knowledge? Your machine would have already trained. So it is going to map that. We have a mapping function of your observed data with your already trained data. Okay, so we implement this Bayesian framework for all the learning algorithms. Okay, it is very useful in constructing a model which is capable of predicting the outputs. Okay, you will be training the machine with certain sets of input, and we create a model so that that model will be capable of predicting input whenever the input is given to it. This is all introduction about Bayes theorem. We are going to use Bayes theorem in many of our machine learning algorithms. Thank you all.